Foundry proudly brings you this issue of the Science Screen Report. The nation's leading independent foundry has been a growing part of the Lynchburg community since 1896. We manufacture quality engineered castings using 2800-degree molten iron and automated equipment to shape intricate parts. Chemical and physical analysis form the backbone of Lynchburg's quality control program. Precision castings are used in a variety of industrial and consumer products. Experience, technology, quality, and the Foundry's greatest asset, people, have combined to make Lynchburg Foundry the leader in its field. And now, the Science Screen Report.
The Science Screen Report, bringing you each month the latest discoveries, developments, and applications of science, engineering, and medicine, made to help solve the problems of modern life. Today, growing arid and semi-arid regions cover 1/3 of the Earth's land surface. While even in vegetated areas, water is in short supply. This aircraft is helping to evaluate one answer to the growing global shortage of fresh water, a new cloud seeding system for increasing local rainfall by 50% or more. Today, scientists of the National Oceanic and Atmospheric Administration and other groups are seeking reliable ways to increase local rainfall. One successful day of investigation started in this Florida field, where a research team is setting up an array of weather monitoring sensors. Pilot balloons are released to estimate wind speeds and directions aloft. All sky camera systems are ready. Rain gauges are emptied and prepared. And a balloon-borne instrument package is sent skyward to sense atmospheric conditions. Weather modification research is the concern of farmers and other citizens, as well as scientists. Here, the Cedar aircraft are being examined by the public, while the researchers discuss the program with interested individuals. At the Florida laboratory, a morning meeting is underway. The weather briefing is first, a rundown of current conditions which may influence the experiment. Meanwhile, data from the test zone is fed to a computer, which predicts cloud behavior in order to estimate the effects of the rain-making efforts. If the outlook is poor, the flights will be canceled. But today's outlook is excellent. This is a go day. Meanwhile, the two rain-making aircraft are readied for flight. The first successful scientific rain-making experiment was carried out by Nobel Prize winner Irving Langmuir in 1946. These tests will be major scientific evidence after 30 years of research that a second technique called dynamic seeding can reliably increase rainfall. The approach involves firing these silver iodide flares into carefully chosen cloud towers to stimulate precipitation. Within half an hour, the two research planes are airborne. At the laboratory, radar images are used to guide the aircraft toward promising cloud configurations. Scientists know that a cloud has a kind of life cycle, born when water in the air condenses, growing and expanding, sometimes producing rain, and finally dissipating. Cloud seeding to stimulate rainfall uses the fact that the tops of cumulus clouds may hold supercooled water droplets, liquid water at temperatures below freezing. If the cloud tops are seeded with silver iodide, these crystals serve as nuclei for formation of ice from the supercooled water. Heat is also released, which gives buoyancy to the clouds, leading to longer life. The upwardly expanding cloud draws in still more air and moisture, and so produces additional rainfall. Air and moisture continue to rise, forming vigorous new cloud towers, which in turn result in still more rain. As neighboring clouds are seeded, they too grow and may merge with the first, further enhancing precipitation. High over Florida, one of the research planes plunges toward a cloud to start its seeding run. Sensors aboard measure wind direction and wind speed, ice crystal concentrations, and cloud water content. One sensor catches water droplets and ice crystal shapes on soft plastic for later study. Data on cloud characteristics are displayed by an onboard computer. These measurements will be used to determine the suitability of a given cloud formation for seeding. In the test zone, technicians scan the cloud patterns with advanced Doppler radar that records wind motions. The resulting three-dimensional pictures will help scientists analyze changing cloud configurations. To prevent biasing the experiment through choosing clouds by eye, the data is analyzed and the target clouds chosen in the ground laboratory, and this choice transmitted to the plane. The choice is made, and the release of silver iodide flares begins.
Fire 2, fire 3, fire 4, fire 5, fire 6, fire 7, fire 8, fire 9, CCD.
For 25 years, United States electrical power companies have used Dr. Langmuir's discovery to multiply West Coast snowfalls in order to obtain more water to run their hydroelectric generators. In the last 10 years, southwestern farmers have similarly increased local rainfall in selected areas. Radar measurements of the test clouds are recorded on magnetic tape for later analysis. To determine any effects of seeding beyond the test zone, studies were also undertaken of satellite images of cloud cover. One research aircraft approaches still another cloud tower. Neighboring towers are selected in the hope of inducing merging. At the same time, cloud physics data is recorded for later analysis. Wind, temperature, humidity. Both instrument and visual checks suggest the clouds are responding to the seeding effort. Research on increasing precipitation is underway in many lands. The National Research Council of Canada, for example, is seeking ways to use cloud seeding to produce rain in order to put out forest fires. As the seeded cloud grows, an alert goes out to the rain collection unit, though the sky is still clear. The field technician heads for the test zone. And at last, the storm breaks. As part of the rain collection effort, raindrop samples are frozen and preserved in dry ice for subsequent study. Cloud seeding efforts may never stop droughts or eliminate water shortages, but they are becoming more reliable ways to multiply crop production and augment water supplies in many regions. In late afternoon, the seeding still goes on. The test zone has become a place of rain and darkness. The radars continue to track the clouds. Different colors indicate reseeding and approaching cloud movements. The screen also shows wind motions within seeded and unseeded cloud complexes. Three-dimensional pictures which reveal how well the test subjects develop and organize. If these experiments prove its reliability, this second basic cloud seeding approach will, in years to come, be added to man's scientific techniques for drawing more rain from the sky, when and where he needs it.
Lynchburg Foundry has been proud to bring you this issue of the Science Screen Report to further your understanding of science, engineering, medicine, and technology.